record. Good. Hi, everyone. And on last Friday, or actually last Friday, we didn't have class. So don't feel bad if you try to connect to the meeting. I forgot to send an email letting you know that we last week was a break week. Yeah, in the previous lesson, we learned there's 3 logical operators. We will see the use of them when we learn the conditional coding. Then later on we learn the if, while, something like that. And we learn some math functions. This math, this is a class, this is a Java library math. So you can just access this math library without writing any code. And then we learn a Java recursion. It's basically a method calling the method itself. So if you have a method called sum, and then inside this method you call the method itself, then that make it a recursion. Today we are going to look at a few more math functions. So a few are very useful ones. Later on, we do some, a small application that we may need them. I think the power of when we learned that last time, let's do a ceiling. Well, this is called a SEIL, cell. That's basically like the ceiling, the upper limit thing. They return a value and of a double value and round it up to its nearest integer. So let's say you have a value like a 5.5 or 5.6, then the cell will return 6 because the 6, that's the next integer larger than that value. So if we have a number like a 12 dot something, then the nearest integer is a 13. Let's try some example here. Yep, paste in. So we have a double variable x. The value is a 4 point something, and then the cell will return 5. Let's see if that's the case. I don't know. We don't need this one. I don't know why that thing got stuck there. That's okay. Save it. Again, compile. And so here is the x should return 5. And this one, we just pick a random number, it's not a big number, dot something, and we should get the next integer should be 1, 2, 3, 5. And this one should be 13, right? So let's see if that's the case. Java may just run that. Yeah, is a 5. So even though it says return the integer, but then it convert the integer back to a double. So add the .0, .0, .0. So it's not exactly a integer. The math functions all return actually double. So it doesn't return integer. It just means a value, equal to that integer. So if you really need an integer, remember that type conversion, you do need type something in front like that to get an integer. Let me save, compile, run. See, now that's a real integer, but 5.0 is not, it's a double, okay? Okay, that's a cell. And then the opposite of cell is actually it's a floor. This is the upper limit. This is the low limit. So it rounded the value down to its nearest integer. What does that mean is instead of the upper one is a 4.5, the lower one is a 4. So the nearest lower integer or integer smaller than this value. So it's 4 point something, then the floor is 4. And for this one, that's 1, 2, 3, 4. And for this one, this is 12. So basically just drop the decimal digits. And for this one, is actually also drop the decimal and then add 1 to the integer. So let's verify this one. Just copy those lines. Save it. Compile. Run. And yes, we got a 4. 1, 2, 3, 4, 12. So that's the integer, the nearest integer value smaller than these double values. Okay, that's the cell and the floor. And this one is useful also. This is exponential or the power of. Let's see, here is a power of, right? This is the power of. This is the power. This is the x is the base and the y is the power. That's the power. And this one actually is the power of E. This is the base is the E. Remember the E equal to 2 point something. So E, that's a constant. So that's a special function. So yeah, this is the E. Remember E is a 2.71a, and so power of E is just that value. And interestingly, the power of 0 actually is 1. So that's a special. Yeah, I think, yeah, power of 0 is 1. So just to verify that. Save it again, compile, run. And yep, oh, it is very long, many decimal digits. And yep, so this is the E value actually. Oh, this one is similar to this one. Oh, this is a log. This is also E based, just like that E. So this is the E based log. Remember also 10 based log and the E based log. This is the E value actually. Yeah, right. Yeah, so E based, log of E based on E is also 1. And try that. Just to verify that. Yeah, so if X is 4.48, then they log of that value is 1.5. If it's 2.718, then it should be 1, but actually to get 1, then you need to plug that in. If you plug that in, then maybe it's more closer to it's closer to 1. Yeah, you do need have more digits to increase accuracy. Okay, save it, and this time we should get some value better than that one. More closer to 1. Compile, run. Yeah, okay. Yeah, it's much better, right? It's much better than that because yeah, we got more digits, then we have much better accuracy. Last one we want to look at. Oh yeah, last one. Let's look. Yeah, let's look at one more. The cosine. Remember the cosine, and then you want give it a reading, not a degree. To convert a degree to reading, then you need to access this pi value. The pi that's 3.1519. Ooh, forgot that. But this class has that constant stored, so you don't have to type the number. So if it's a pi, then that's cosine, that's -1. If half pi is 90 degree, the 90 degree cosine is 0, and 0 degree cosine is 1. Remember that. If you haven't learned that in your math class, you will. So let's plug that in. Compile. Yep, so -1. Well, yeah, it's not, again, it's not exactly 0. It's very close. Look at that. It's like you got 17 zeros before the dot. So like a 0, 0, 0, 0 dot. 17 zeros. And then, well, yeah, 16 zeros. So it's a very small number, very close to 0. If you say, hey, how about I don't know the reading. I just want to know the, let's say, degree. The degree value. What's the value of 60 degree? Let's say you have 60 degree. Then you want to print out the cosine. Cosine 60, then you have to do some degree. Yeah, is that something wrong? Why is that wrong? Degree. Oh, degree need a D. That's better. Oh, that's a warning. So you define that or you haven't used it. It's fine. We use it. So to get that, you cannot just type degree here, because remember, you need to give the function value in reading, not in degree directly. To convert that, you have to remember convert the degree to reading. You do this, you divide it by 180, right? And then time pi. Oh, that's not there, just time pi. That's how you convert a degree. So because of 1 pi equals to 180 degree. So if you have a degree value here, you want to divide it by 108 and then time the pi. So that's a conversion. And let's see if that works. I think cosine, let's see, cosine 60 is half. Yeah, I think so. I forgot. Let's find out. Compound it. Run it. Yeah. So yes, 60 degree cosine 60 degree is a half, 0.5, right? That's very close. So that's how you use this, use this function here. All right, let's skip a sign. Yeah, if you like, you can try that by yourself. Let's move on to the next one. Let me check the time, 20 minutes, that's good. It's under control. Strings. I think in any programming language, the string and the string functions are very, very important and useful. Yeah, many times more important than those math functions. What is a string? A string, well, is bunch of characters. A string variable contains, some characters and with double quotes at the beginning and at the end. Double quote something, then that make it, that's the string value, and then you assign that to a variable, and you want to say this variable is of this type. Remember, the string has to be uppercase S, start with uppercase S. So string and variable, you can pick any name, and then sign something, blah, blah, this numbers, uppercases and lower cases. And later I'll show you, you can even put some symbols or, let's see. Let me check something here. I have something to check. Okay, that's fine. Okay. That's a string. And this is, remember in the variable types, in the types, we didn't, did we? Yeah, so we didn't learn we learned the primitive types and a non-primitive. The string is non-primitive, so it's different. It's a special type, and because it's actually an object. So it's an object. Since it's an object, and it actually string can have some method attached to it. That's different from other type, integer, double, float, those kind of variable types. And the first method we want to learn for string is actually called a length. Let's say we have a string. We want to know how long the string is, how many characters the string contains. For this one, you can count. Well, you don't need a function to know, right? 1, 2, 3, 4, 5. Okay, this one got the length of this string is 5. But what if I give you a string that long? Then you don't want to count one by one, right? So it's going to be convenient if we have a function, just return the length of a string, and then we do. So when you have a string variable, you have string variable, then since the string is an object, we will learn an object later at the end of this lesson. Then you can call a method attached to this string. So this method called a length doesn't require any parameter, just empty. So this one basically say, okay, return the length of this string object. So let's try it. Yeah. So we have a very long string. Basically numbers digits. So we can guess, right? 26 times 2, 52 plus 10 should be 62, right? Okay. Should be 52 or 62. Oh, I don't need a 2. Function name. There we go. And then we compile it. Right. The length of text string is 62. Yep. So this is the most useful string method called a string length. Okay. And next one, next one is actually to change the cases. The cases of all letters in a string. Let's say we have this string, right? We have a mix of uppercases and lower cases. Sometimes, you'll probably say, hey, give me all the uppercases. For example, if you fill out a web form, and some people like uppercases and some people like lower cases. Some people like a mix of them. And when you collect that information, if you want to compare the data you collected with something, you probably want to convert the different cases into a single case, like either all lower or either all up cases. So you do need the capability to convert cases, string cases, right? So if you want to all upcase, then you can call a function called a toUpcase. If you want to all lowercase, you can call the method, the string method, toLowercase. So there are two methods you can use. Let's see what happens if we convert the cases on this string, long string here. Okay. So we just replace that one. So we have that string of mixed cases, and then we have the first two are uppercase. We should return all uppercase. Oh, it doesn't impact the number because the number there's no case. The case is only on the letters A to Z, right? And all lower. Let's try it. Compile and run. Yeah. Oh, you can see that the first one return all A, B, C, D, and then the lowercase is also converted to uppercase A, B, C, D. And the two lowercase function return all lower, convert the uppercase A, B, C to Z and to lower, and plus it didn't change that. So they keep that one. So now you got all either all uppercase or lowercase, right? And yeah, you can let's say you have different upcases inside the lower case part. It doesn't matter. It just work like that. See, it will convert all up, all lower to up, or convert all up to lower. Okay, that's those methods. And the next string function is index of. It return the index, or the index is the position. Actually, the string object, it looks like an array of letters. So the position 1 is not 1, actually position 1 is 0. So 0, 1, 2, 3, and something like 11, yeah, 11, 12. That's called the indexes. It's just like array. Index return index position, first the specified text in a string, include white space, right? Index of. You do need to specify as a parameter what letter or substring or text you are looking for. So it's basically find a substring inside a string. Let's see. If we put that here. So what the first one is doing, say, where is ABC? Yeah, ABC is here. But tell me the location, and the location of position inside this string. The next one is uppercase ABC. Where is the uppercase ABC located? So here. So it should return actually 10. Remember, the position start with 0. The first one is not for 1. The first one is 0. So 0, 1, 2, 3, 4, 9, and 10. So this one should return 10. And ABC, that's 26 plus 10. So that's 36. And where's 0, 1, 2, 3? 0, 1, 2, 3. So it's position 0. Okay. The first index is 0. So let's verify that. Yep. So we find the ABC 36, 10, and 0. Okay, that's the index of. So again, this is a method of a string object. Yeah, so the txt is a variable, is an object, and a dot, and then the method. Okay. Okay, next is concatenation or concat. Yeah, remember when we learned the operators? This class, when the first part, when you add two things together, if the first one is a mass variable, not a string, then this plus actually will do the mass. If the first one is a string, then the plus behaves, knows the first one is string and automatically convert the one after the plus sign to a string and then concatenate them together, like append the two strings together, not doing it, doesn't do the math. So that's special about the plus sign. Others just do their math thing, but only the plus sign can do either math addition or string concatenation. It can do two things by itself. It detect the first part of the math, the first part of the either math variable or a string. Let's back here. So plus sign, yeah, concatenate two strings. So you have a string 1, string 2, string 3, and this is the result. So you can concatenate these 3 strings together just with that, just like doing math. Well, it's not a math. It just looks like doing math. Actually, it's doing the math concatenation. Okay. You can do that, and and then save to a new variable, new string variable, and then print out. Or you can like do this. Oh, see this one? This is a string object. When you do the addition, it added the string. And for this one, it treat the text the string 1 as an object, and then call this method called a concat, and then append the second string to this one and assign to the new value. And then you can keep doing that. So this one is doing exactly that one is doing. Okay. So let's find out. So we have 3 small strings. We have 3 small strings, and we want to concatenate them together. Let me see. Save it. Compile. Run. Yeah. So the first one, just add the 3 together and print out. This is the long one. And this one, it just concatenate the first and the second into that. And then continue to concatenate with the third one. So add the third one. So at the end, the result, is the same. Oops. So this one and this one, those are the same. So that means you can do either that one or do that one. Oh yeah, with all that, right? So you can either use the plus sign, or you can call this concat function. So 2 ways to do it. Either one is okay. The string concatenation is useful because, for example, let's say the first one is called a first name. Remember, on the web, you always fill out a form. What's your first name? What's your last name? Let's see, your first name. Put my first name. And, oh no, wrong. Your last name, or my last name, right? And actually middle name. I don't have any, but let's pretend I have one. Middle initial, let's say called a middle initial, okay? And then say, then what's your full name? So in many of our applications, when you collect user information, you want to collect the 3 things. If you just say, what's your name? Then you get something like some people use this last name first. That's one way to do it. Or some people do first name first. You can do that. And and you don't know which one is last name, which part is the first name. You cannot verify or validate. So in order to avoid those confusion, you always want to ask their first, last, middle initial, or middle name separately. And then we do need to display or display their full name. Then you can you decide the format. It's not up to user. It's up to you to display their full name. So in this case, we have those. Now we have those names. So let's construct the full name. And then we want to, by the American tradition, then we want the first name first, right? And then middle name, and then last name, right? And then we print out. Let's get rid of that. We don't need that. We just need one. So let's save it. Compile. There we go. Full name, 新街爱用过. But you say, oh, wow, that full name, there's no space, that's not right. Yes. So when you do want to, concatenate the first name, last name, middle name together, you do need to remember add some space. Right? Add a space between. Then you will have better format. That's better, right? First name, middle name, and last name. So that's the use of string concatenation, right? Yeah. Or similarly, the other way to do it is do this. First name, first name, and then concat. You want a space, right? Then, right? Yeah. And then again, so that's another way to do it. First name, full name, yep. Yep. So let's see if we get the same result. Yes. So you can either use just a plus, or you can call those functions. Well, you use a plus also. If you don't really avoid the plus, then you have to call extra concat, right? Basically, you have to do that. And the first one just concat with a space, and the second time just concat with that, and similarly do this. This may be not necessary, so. Oh, wrong. So in this way, you don't use plus sign at all. So basically, add a space to first name, add a middle name to that part, and then add another space, and then add the last name. You don't need to add the first name here because you're calling that first name already. So it's add a space to first name and assign that to full name. So here is full name is not a real full name yet. This is just at this point, after this first line, the full name actually just first name plus a space. And after this one is a first name, space, and middle name. and then another space at the end, and then last name. So only after that one, the full name is a real full name, right? So let's verify. Always save the code, compile the code, and then run the code. Oh. First name space, what happened with our space? I don't know. Interesting. Where's my space? Oh, look at that. This is called a bug. Look, I call the first name, I assign to full name, and then here first name again, and then assign full name. So that basically make this line, you know, that avoid the change to this. So that make this line, you know, like useless. So the error is you don't want to call first name again. So first name call one only once, and then after that always access full name. Very subtle error. The code looks fine, right? But the result, you know, the result doesn't change. They always tell you the truth. So now should work. Of course, save the code. Compile. Ah, there you go. That's better, right? Yeah, so that's a string. And there are many string functions. If I open the page, this one, look at this, string methods. Oh my goodness, look at that. Oh, the concat, we just tried. String compare, string contains, content equal, equal format, get a bytes, get a characters, intern. Oh, what's that? Is a string empty? Oh, string length, we know that, we just tried that. No, even replace, you can replace a string, or you can split a string, or substring, you find substring. Oh, to lower, to up, we tried. Index F we use, right? Where's that index of? Oh, there, we use index of. So if you want to see all the string methods, you can visit this page. Let me check time. Oh, time 46 already. Wow. All right. Okay, then let's skip the substring. Then it's the same idea. Just call it substring. Actually, substring is pretty useful. Maybe we should look at it next time. But before we end, let's jump to the OOP. This is something new, and let you think about it over the weekend. OOP. What is OOP? OOP stands for Object-Oriented Programming. So far, this is not object-oriented. Look at this. Well, yeah, if you just align, you know, that one by one, assign the value, print out, do some change, and print out. This is almost most like you know, procedural. Procedural means, you know, one after another, you know, single thread. And the OOP actually, you know, group the things together. It's about the procedure is about writing procedures or methods, you know, this method or procedures that perform operations on the data, you know, concatenation or, you know, or do the math. That's procedure. The OOP is about creating objects that contain both data and methods. So OOP is about to create an object, okay? And the inside the object, you have both the data and the functions to work, to manipulate those data. So that's a difference. And why OOP? Why do we want to use OOP? It has some advantages. It's faster, easier to execute or to run. It makes the code easier to maintain or modify or debug. We will see that with some examples. And less coding, that less coding means you write an object code and the object can be used in multiple applications. So that's also called a code reuse. Also, the structure is clear for the programs. So this is pretty conceptual, and we will learn those with real examples. Quickly, when you talk about objects, and then always there's like a class, like this class here. Classes versus objects. This is two main aspects of OOP programming. A class, the definition of a class is a template for objects. So you have the template, then you can create multiple objects, similar objects of the same using the same template. Then an object is an instance of a class. So for example, we have real objects, like apple, banana, mango, orange, peach. Those are objects. And then we can make an abstract representation of those objects with a class called a fruit. You can think of the class is like a fruit. Fruit is not something, it's not a real thing you can eat. It's just like a fruit is an overall name or type or class of real objects. See the difference? So the class is more virtual, conceptual, and objects more like a real objects. And similarly, car, you have a car that's a class. Then the real car is, it's a Volvo car, it's an Audi car, it's Toyota, it's Ford, Chevrolet, and so on. Those are all the real car brands. And then car itself is just like a catch-all, or type or name. So that's the difference between class and objects. So this is just like the basic concept. And next time we will look at some real examples and how the classes, objects are defined and used. Okay. I think that's it today. Yep. If you have any questions, you can stay. Otherwise, I see you next Friday. Bye-bye, everyone.